Hi everyone, it's me Dr. Sikandar Ali. I'm teaching you software construction and development. It is the first lecture of the midterm. Unfortunately, you didn't give midterm, but it's the course which you have to give the paper. It will be the part of the paper of the final term. So this one is the first lecture after midterm. In this lecture, today we will talk about performance analysis and tuning. Performance analysis is a very vast field, and there are a lot of methods to improve the performance of a varied program. One of the techniques of performance analysis is code efficiency. So we will focus more on code efficiency and will focus less on performance analysis. In order to explain further, first of all, we need to define what is performance analysis. So it is the investigation of a program behavior using information collected as the program executes. During program execution, we will collect different uh, information and we will analyze these collected information in order to improve performance of a program. So in performance analysis, usually we will talk about a varied program. There will be no error, no compiler error in the program, but still there will be some room to improve the performance of a program in order to increase the efficiency. So there will be two types of code efficiency. Sometimes we want to reduce the size of program, and sometimes we want to reduce the execution cycle. So there are two measures of code efficiency. The first one is related to the space occupied by the program, and the second is related to the time taken by the program to execute. So what is the goal of the performance analysis? The goal of the performance analysis is to identify possible hotspots in the program to be improved. So in performance analysis, usually we will talk about further improvement in the program. One of the techniques of performance analysis is code efficiency. We will think about in performance analysis, we will think about efficiency from different perspective, from design, from requirement. But the most popular and related to our field, our subject, software construction, is code efficiency. So code efficiency determined by architecture, detailed design, decision, and data structure and algorithm selection influence and execution speed and size. Think about efficiency from each of these viewpoints. So we will think about increasing efficiency of the code from program requirement, system design, class and routine design, operating system interaction, code compilation, hardware selection, and code tuning. So all of these we must think about in order to during the program requirements we will think about how we can improve the code efficiency. During the system design we will also think about the efficiency. During the class and routine design we will also think about the code reusability and code efficiency. During the operating system interaction, code compilation, hardware, we will think about the code efficiency or the performance efficiency. So the code tuning is the most popular method related to code efficiency. So this lecture will mostly focus on code efficiency. The next slide we will study code tuning in detail. So related to performance analysis and tuning is the area of code efficiency, and code efficiency can we can improve the code efficiency by code tuning. So first of all, we need to define what is code tuning. Code tuning improve performance at the code level. We can improve performance at the requirement level, at the design level, at operating system interaction level, as we discussed in the previous slide. So Code tuning is one of the techniques to improve the performance at the code level. Since our subject is mostly related to coding, so we will talk about improving the performance from the perspective of code. So it is the practice of modifying correct code in ways that make it run more efficiently. We will modify the correct code. The code will have no error, no compile error, or no runtime error, but still we will try to modify the code in order to make it run more efficiently, in order to reduce the running time, in order to reduce the size of the program. So we will doing different experiment and different applying different techniques in order to modify the code to run efficiently. Code tuning usually involves only small scale changes that affect a single class, a single routine, or more commonly a few lines of code. Code tuning techniques were usually doing some changes, and that changes will affect sometime only a single class or a single routine or a part of the software, or more commonly we will change few lines, and that few line changes will improve the running time at large. There will be a large efficiency with the small changes. So we will do small changes in the code, but the efficiency will be very large. Some researchers do a lot of experiment, and we will just see the results, how they change something, how they change only one line, and how they measure the efficiency from the perspective of different languages. So a rich set of code tuning techniques is available, including those for tuning logic expression, loops, data transformation expression, and routine. So there are a lot of code tuning techniques. Some will be applicable to the logic expression, some will be related to the loops, some will be related to the data types, data transformation, some will be related to the expression, and some will be related to the routine or the large part of the program or even class. Using a low level language, beside the logic, expression, loop, data transformation, expression, and routine, we can have low level language. So in the previous slide we discussed some code tuning techniques which we want to give in order. So the first one is logic, second one is loop, third one is data transformation, fourth one is expression, the fifth one is routine, and the sixth one is recording and assembler. Means using low level language is also one of the techniques, but it's very difficult. So in the next slides we will discuss these techniques in more details. So uh, in today's lecture we will only cover the first one, the logic. So today we will cover only the logic code tuning techniques, and we will learn some techniques which is related to modifying the logic of the program in order to improve code efficiency. So related to code tuning techniques, we are going to discuss the logic. The first one practice of related to the logic is that stop testing when you know the answer. Mean stop execution when you find the answer. Let's see some examples. We have one logic expression which is taken from some code. So they have two conditions. If 5 is less than x and x is less than 10, then do something. If we look at the first condition, if the first condition is true, 5 less than x means if the value is greater than 5, then we must need to check whether it is less than 10 or not. But if the first condition is false, so if the first condition is false, it means the value is less than, the value is not greater than 5. It means it is less than 5. So if it is less than 5, then there is no need to check the condition whether it is less than 10 or not. So this techniques we need for this statement we need some techniques like short circuit evaluation. What is short circuit evaluation? Short circuit evaluation is that when you know the answer, then stop execution. So here if we write like that, if 5 less than x, then you check the second one. If this one is false, then don't need to check the second one. Some languages like C++ and Java implement the short circuit evaluation by default. So now we need to define what is short circuit evaluation. Short circuit evaluation means that the compiler generates code that automatically stop testing as soon as it knows the answer. Testing here means evaluating the condition. By testing means checking the condition. Short circuit evaluation is part of the C++ standard operator and Java conditional operator. So what mean by short circuit evaluation? You don't need to check if you know the answer. Now taking some example which the short circuit evaluation is not implemented. So let's discuss some example of a code which not stopping after they know the answer. This example is taken from the C++ and this code is not stopping even they know the answer. So in this code, first we define the flag negative input found is equal to false is a flag in which is at initial stage it is false. So then we run a loop. I start from 0, I less than, I count less than count, and we incrementing the loop by 1. There is a condition if input value of I is less than 0, it means if it is less than 0 it means it's negative value, and then we change the flag negative input found equal to true. So we found the negative value in some array or something, then we need to stop the execution of the loop, but here we not have something which stop the loop. So this code will produce no error, but it consuming the processing time, it consuming the resources for new use. So we need to stop the execution if they know the answer. Even they know the answer, it will complete the loop. So this is the disadvantage of the for loop as well. So what will be a better approach? A better approach would be to stop scanning as soon as you find a negative value. So the last after the last step, negative input found equal to true, then we need some mechanism to stop the execution of the loop. As you familiar with C++ programming and C++ and Java, we put a break statement after the negative input found equal to true line, and then the break will terminate the body of the loop. You know, if we use the break statement inside the body of the loop and terminate the body of the loop, and if you use inside some switch statement, then it if for example some languages which not support the break statement, then you can implement goto. You put some label outside the loop and then you write after negative input found equal to true, you write goto label, and then if this value, if a negative input found equal to true, then it will go to outside the loop. So you can implement a break statement using go to statement. Java doesn't support go to statement, but Java has break statement. So in Java you must use break statement. Change the for loop to a while loop and check for negative found as well as for incrementing the loop counter fast I count. Then another techniques would be, if you didn't want to use break or go to statement, then you use the while loop instead of the for loop, and then you control the incrementation according to the condition I count. Let's see how much improvement in running time we will receive if we only implement one technique like stop execution if you know the answer. So some researchers do some experiment in taking C++ and Java is a experimenting languages, and they do experiment and the count of 100. They run the code 100 times, or they run 100 example for this experiment. So the starting time is that and coding time is that, and we only need to focus on the time saving. So if we only implement this single techniques, if you know the answer, then stop execution, then using C++ language we will receive 14% improvement or 14% time saving. In Java we will even receive double of the C++, we will receive 29% time saving. Another techniques after short circuit evaluation are stop execution if you know the answer. Another technique is order test by frequency. Arrange the test or the condition from the perspective of from two perspective, like arrange, you give the condition, first condition which is first it or which is more likely to be true. If you have two or three conditions, so the first condition should be that one which executes more quickly, or if there is a high chances that the condition will be true. If some condition will be false, then you put that in the second priority. So order test by frequency means arrange test means condition, so that the one that first is and most likely to be true is performed first. So this is another technique, and it will implement this rule. This principle applies to case statement and to chain of if then else statement. Where this condition is applicable, or this practice is applicable, it is mostly applicable to case statement and nested if else, or nested if then else. If we implement only this single practice, then we will receive 48% time saving in C# language, 50% time saving in Java language, and 26% time saving in Visual Basic language. So the person who do these comparison experiment take the three languages as input and run the experiment on at least 100 examples, and then they give the results in terms of time saving, in terms of improvement in time. Let's discuss an example taken from Visual Basic related to order test, means the ordering of the condition. So this example is a poorly ordered logic test. The condition are ordered poorly, means if we using some character on the keyboard, so the plus and the minus are the symbols. The mathematical symbols are used less often. Mostly we type some character, so the character case must be first. But here the the mathematical symbol are first, and then we have some numbers. So in normal case we use the character more than numbers, and we use even the function we use more than numbers. So this is the example of poor order logical test. If we change the order and we only follow the condition, order test by their frequency of use, the condition that is used, that will be true, means we use that data most often, means frequently, so we will put the condition first. So as I tell you, we use the number more than we use the character more than numbers are mathematical expression. So let's see a good order logic test example. This is the same language code, the same code, but here we put some order. So the first case is alphabetic, the second is spaces or other punctuation mark, special character, and the third is the number, and then math symbol, and then error symbol. Error symbol, processor error will come less often. So this is the example of a good order. Another code tuning techniques related to the logic is converting a complicated expression to lookup tables in the form substitute table lookups for complicated expression. In some circumstances, a table lookup may be quicker than traversing a complicated chain of logic. If you have a complicated chain of logic, it is very difficult to comprehend for the reader, but it also slower than lookup table. It is very easy for the compiler to it is very easy for the processor to look from the table instead of traversing a complicated logic. The point of a complicated logic is usually to categorize something and then to take an action based on some category. So we can also categorize something using lookup table. For example, we have three classes of object A, B, C, and they have some value and some interconnected value, means we have some three categories A, B, and C. This is the example of a complicated chain of logic, and they have category 1, 2, 3, and category 0. Let's see how we can make a lookup table instead of this complicated logic. Here we have substitute a table instead of the complicated logic shown in the previous slide. So here we convert the complicated logic to lookup table, and for each and every condition like not B not C, we substitute some value, and instead of traversing complicated logic, it will be quicker to look up from this table. So this is just example of the substitute table lookup example instead of the complicated logic expression. Let's see some performance improvement. So using C++, we have 1.5 to 1, we can say that in C++ we can save time by 33%, while in a Visual Basic we can save time by 50%. So this is the third techniques related to logic. Here we are changing the logic in order to improve the performance of a code, and these techniques like changing the code is called performance or code tuning for performance analysis. The last techniques related to the logic is to use lazy evaluation. The writer of the books Code Complete write that I learned these techniques from the behavior of my friend. His friend was very lazy. He don't want to do something until they critically need it. Something need to do critically, then they do that. Like some of the people don't want to prepare for paper, and they only prepared if the paper is apparently coming next day. So according to this logic, don't do the things if the things are really not needed. So it avoids doing any work until the work is needed. Don't need some calculation if you don't need the value in the near future. Suppose your program contains a table of 5000 value, generates the whole table at startup time and then use it as the program executes. So the people usually doing that, they generate all the value and then using the value during the program execution. So if the program uses only a small percentage of the entire entries in the table, it might make more sense to compute them as they are needed rather than it all at once. So it is best approach to generate the value if they need it. If they not need it, then don't need to generate all the value at the startup. So they will save a lot of time, a lot of processing time. Once an entry is computed, it can still be stored for future reference. Caching it is another technique, but here you also do. If you generate some value, then you must keep the value in cache memory. So if later you need the value, you can use from this temporary storage. Loops in order to achieve code efficiency. So we have a lot of techniques to modify the loop. So these include unswitching loop, jamming, unrolling, minimizing the work inside loop, sentinel value, putting the busiest loop on the end side, and strength reduction. So in the upcoming slides we will learn these techniques and detail. So as we know that loops are executed repeatedly many times. So there the chances of the hotspots in a loop are more than any other code. So we can induce a lot of hotspots in a program due to poorly designed loops. The techniques in this section make the loop itself faster. So we will learn some techniques which will modify the loop to make it more faster. The first technique called unswitching. So first we learn what is switching and unswitching. Switching refers to making a decision inside a loop every time it is executed. If the decision doesn't change while the loop is executing, you can unswitch the loop by making the decision outside the loop. So it is very simple technique. If you have some decision or if statement inside the loop which needs to be run only once, so why we include the statement which needs to be run only once inside the loop. So The simple practice is that if the decision inside the loop is not executing every time, so we put the decision statement outside the loop. This technique is called unswitching. So we are going to implement unswitching the loop by making the decision outside the loop. Usually this technique requires tuning the loop inside out, putting the loop inside the conditional rather than putting the conditional inside the loop. So in switching loop, you put the condition inside the loop, but in unswitching you will put the loop inside the condition. So it's better if the condition is not executed every time, so you put the loop inside the condition, and if the condition is executing every time, so use the switching practice, put the condition inside the loop. So now we are going to unswitch, means putting the condition outside the loop, means putting the loop inside the condition. So here is one example. For I start from 0, I less than count, and I plus plus. This is a C++ loop in which the loop is switched, means we have put it the condition inside the loop. If some type equal to some type underscore net sum equal to net sum plus amount of array of I. So this is a very simple example, but here the condition some type equal to some type underscore net. This condition to be checked only once, but we have put this condition inside the loop. So now using this practice we will unswitch the loop, means we will put the condition outside the loop. So this is the explanation. In this code, the test if some type equal to some type underscore net is repeated through each iteration, even though it will be the same each time throughout the loop. So this condition is not changing during the lifetime of the loop. So it's unnecessary if we execute this condition each and every time, means with each and every iteration we don't need to check the condition. So it's better if we unswitch the loop and put the condition outside the loop body. So you can rewrite the code for speed gain. If we rewrite the code, so the execution speed will be much better. So here we have unswitched the loop. If we look here, this is the body of the loop, and we have put the condition some type equal to some type underscore net outside the body of the loop. This is a good for about a 20% time saving. So let's see the time saving for different languages. In C++, we receive 19% time saving. In Java, we receive 21% time saving. And Visual Basic, we receive greater than 1% time saving. In Python, we receive 28% time saving. So Visual Basic not show a much better improvement. The second technique is jamming. Jamming or fusing is the result of combining two loops that operates on the same set of elements. If you have two loops and that operates on the same set of elements, their starting point, their condition, and their ending point is same, or if they operate on same set of data, so why not we combine the loop? So in this techniques we combine the loop into one. If there are two separated loops, so we combine the two loops into one whole, which save the time of running the individual loop. So we control the loop by loop control variable. So there is a overhead to control the loop. So this overhead will reduce. Again lies in cutting the loop overhead from two loops to one. This is a Visual Basic example in which we have two loops. For I start from 0 to imply count -1, and the next also for I start from 0 to imply count -1. So both execute the same number of times and both use employee underscore employee name. One use employee name and one use employee earning, but their running time, their count is similar. It also runs from 0 to imply count -1, so we can combine these two loops into one whole. So in this example we apply the techniques and we have jammed the loop. We have combined the two separated loops into one loop. Now look into the time saving gains. In case of C++, we receive 28% time saving. In case of PHP, we receive 32%, and in case of Visual Basic, we receive 4% time saving if we apply this simple technique. The third technique is unrolling. So what is unrolling? Unrolling is reducing the number of times the loop is running. So the goal of loop unrolling is to reduce the amount of loop housekeeping. We can reduce the number of times the loop is running. So we will increase the line of code in order to decrease the number of times the loop is running. So if we reduce the number of times the loop is running by 1, so we call the loop as unrolled by 1. If we reduce by 2, so we said the loop is unrolled by 2. Here is example of a Java loop that can be unrolled. So we have a while loop, and while loop condition is I less than count. If it is less than count, the loop body will be executed. Inside the body we are assigning AFI. We are assigning the I value to AFI, and then we are implementing the loop. So the loop is running up to the count. Count means the number of time the loop is the maximum number of time. So we can reduce the loop by 1, and to unroll the loop partially, you handle 2 or more cases and each pass through the loop instead of 1. This unrolling hurts readability, so I not recommend these techniques. If they will increase the speed, but it will decrease the readability of the program, so I'm not agree with this technique. Java example of a loop that's been unrolled once. So here we reduce the condition I less than count -1. So previously it was running up to the count, but now it will run up to count -1. So we reduce the loop running by factor of 1, means we save one iteration but we increase line of code. So here we will handle the one iteration. We assign I to AFI and we assign I plus 1 to I plus 1, and we increment the loop by 2 here. So through this statement, the increase of the statement, we save the loop iteration by 1. The technique replaced the original if I equal to I line with 2 lines. and I is incremented by 2 rather than by 1. The extra code after the while loop is needed when the count is odd and the loop has one iteration left after the loop will terminates. So the loop will still have one iteration and the loop will terminate. So we reduce the number of time the loop is running. So just in this example we reduce the loop execution iteration by 1. So it means we unroll the loop once. If we unroll the loop once in case of C++, time saving will be 34%. In case of Java it will be 43%. In case of PHP it will be 16%, and in case of Python it will be minus 27%. It means in case of Python the result will be negative. Instead of time saving, it will increase the running time. The reason is that in Python loop we not have loop iteration variable. The Python loop style is different. So they just search the value and the list of value given, and they just printing the value one by one. So there is no incrementation or decrementation in the Python. They control the loop iteration by themselves. So that's the reason the Python code will increase the running time if we use loop unrolling. So that's why I say I don't like this technique. Here we have a Java example in which the loop is unrolled twice. So here we reduce the number of time. Previously if it was executed less than count, and now it is executing up to less than count minus 1, and the two statement we handle here, and now here we are incrementing the loop by 3. So 0 plus 3 equal to 3, and the 1 and 2 element we control here. We directly write the 0, 1 and 2, and we start from the 3. 0 plus 3 equal to 3. So we increase the number of lines of code, but we decrease the loop iteration. So if we unroll by 2, then the time saving in case of C++ was 42%, in case of Java 43%, in case of PHP 31%, and in case of Python still a negative result. So these unroll techniques doesn't work well with Python language. The next technique is minimizing the work inside the loop. One key to writing effective loop is to minimize the work done inside a loop. So using this technique we will reduce the number of work inside the loop. If you can evaluate a statement or part of a statement outside a loop, so that only the result is used inside the loop too. So if you have complicated expression inside the loop, so you just do the calculation outside the loop and use the results of the calculation inside the loop. For example, you are calculating the count, so just calculate the count outside the loop and then put the count inside the loop is a condition. It's good programming practice, and in some cases it improves readability. It also improves the readability of the program. So this is a very good practice. Here we have C++ example in which the net rate of I equal to base rate of I star rate of I, and we have assigned the 3 pointers. So it is a very complicated expression, and we are using a pointer here. In this case, assigning the complicated pointer expression to a well-named variable improve readability and upon improve performance. So what we do, we do some calculation outside the loop and then put a simple expression inside the loop. C++ example of simplifying a complicated pointer expression. So we use the big pointer expression outside the loop and only a simple assignment statement and multiplication inside the loop. So these techniques will improve the performance of the loop by minimizing the work inside the loop. The extra variable quantity discount make it clear that the base rate array is being multiplied by a quantity discount factor to compute the net rate. So this also improves the readability of the program. This version of the loop is very easy to read, and the previous slide version of the loop was also difficult to read. So that at one side these techniques improve the performance or the code efficiency, but at the other side it also improves the readability of the program. It was not at all clear from the original expression in the loop. So if we apply this technique in case of C++, the time saving will be 19%. In case of C Sharp, the time saving will be 13%. And in case of Java, the time saving is tremendous by 43%. The fifth technique to make the loop faster is by use of sentinel values. When you have a loop with a compound test, you can often save time by simplifying the test. So sometimes we simplify the compound test and we increase the efficiency of the loop. If the loop is a search loop, one way to simplify the test is to use a sentinel value, a value that you could just pass the end of the search range and is guaranteed to terminate the loop. They will you just put near to the end of the search and it will guarantee the loop to terminate. Here is some example. Here we are checking three conditions. The first one is it will search the checking the not found condition, and second it will check I less than count, and the third it also comparing the element each and every element with the test value. In this code, each iteration of the loop test for not found and for I less than count. The purpose of the not found test is to determine when the desired element has been found. The purpose of the I less than count test is to avoid running past the end of the array inside the loop. Each value of atom is also individually tested with the test value. So the loop really has three tests for each iteration. So this loop example have a problem. They have three test conditions. So now in the next slide we will use the sentinel value and we will try to combine all the three test conditions at once. So here is the example of using a sentinel value to speed up a loop. Here we are checking the test value outside the loop and we are comparing each and every atom with the test value, and then we are restoring the some some middle value. We assign some middle value and then we are restoring the middle value. So with the use of sentinel value, here we are trying to make fast the loop. In this kind of search loop, you can combine the three tests so that you test only one for iteration by putting a sentinel at the end of the search range to stop the loop. So we can combine all the three test conditions at once and using the sentinel value which guarantees the loop will terminate. In this case, you can simply assign the value you are looking for the element just behind the end of the search range. So if we use these simple techniques in case of C Sharp, we will receive 23% time saving. In case of Java, we will receive 44% time saving. And in case of Visual Basic, we will receive 65% time saving. The next technique, number 6, is putting the busiest loop on the end side. If you have nested loop, so you keep the busiest loop as an inner loop, because with each iteration of the outer loop, the inner loop will also execute it. So if the busiest loop you keep inside, it will save a lot of execution time. When you have nested loops, think about which loop you want on the outside and which you want on the inside. Following is an example of a nested loop that can be improved. So here we have a loop from 0 to 100, and we have another loop from 0 to row less than 5. So the key to improve the loop is that the outer loop execute much more often than the inner loop. So here the busiest loop is the one with the column less than 100. So each time the loop execute, it has to initialize the loop index, increment it on each pass through the loop, and check if after each pass the total number of loop executes is 100 for the outer loop and 100 multiplied 5 equal to 500 for the inner loop, for a total of 600 iteration. So in this, the outer loop execute 100 times and the inner loop executes 5 times. So we multiplied 5 by 100, so actually the inner loop executes 500 times and the outer loop run 100 times. So the total execution is 600 iteration. But if we change the position of the loop, then by manually switching the inner and outer loops, you can change the total number of iteration to 5 for the outer loop and 5 multiplied by 100 equal to 500 for the inner loop, for a total of 505 iteration. So analytically, you expect to save about 600 minus 505 divided by 600. So mathematically, we can save 16% running time of the loop by just switching the position of the loop. So this simple techniques tell us we must keep the busiest loop as a inner loop. The last approach to improve the efficiency by modifying the loop is strength reduction. By strength reduction, we mean that replacing an expensive operation such as multiplication with a cheaper operation such as addition. So multiplication is expensive and addition is cheaper. So you should convert multiplication to addition, since we know that 3 multiplied by 6 is multiplication, but if we add 3 2 times or 8 2 3 times, we can also achieve the same results. So we can change multiplication to addition. Addition is cheaper operation while multiplication is expensive operation. This is a very simple example of Visual Basic in which we have a multiplication of different variables. So following the rule of strength reduction, addition is usually faster than multiplication, and if you can compute the same number by adding the amount on each iteration of the loop rather than by multiplying, the code will run faster. If you have a loop and you have such a condition, then it will execute many times, so it's better you should convert multiplication to addition. So here in this example, inside the loop we have converted the multiplication to addition, and the multiplication we just use once, which is outside the body of the loop.